Alright, I'm going to teach you some 75th percentile work. Right here I have a number outside of a radical, and underneath the radical is 24 a to the fourth power, b to the second power, and c to the third power. The goal is to regroup all of these numbers into perfect squares so they can escape the radical. And the way we do that is by breaking it down with prime factorization. So this will turn into 8 and 3, and this will turn into 4 and 2, and let's say this is 2 and 2. I know that a4 is broken down to times a squared times a squared, and this is a and a and a and a. B is b and b, and c is c squared times c, and then c times c. Alright, that's a lot. So if we rewrote this, it would be 2 times 2 times 2 times 3 times a times a times a times a times b times c times c times c. It's a lot. Okay, so this is like a buddy system. We know that that is a perfect square. 2 times 2 is 4, and I know the square root of 4 is 2. I know that a times a is a squared, and the square root of a squared is a. I know that this is true for this. I know it is true for this. And I know it is true for this. Okay? And it looks like we have some leftovers who don't have buddies. So all the buddies, one of the pairs gets to go out. So negative 3 is now with 2. Is now with a. Is now with another a. Is now with B, is now with C. And then the people who don't have buddies, they stay. So 2 times 3 times C gets left. Alright? We have to regroup. So negative 3 times 2 is a negative 6. A times A is A squared. And B and C get smushed together all in one clump. Under the radical, we got 2 times 3 is 6. And then we have a c paired with it. So we call this simplifying the radical. Okay? I have another example. It's a little bit less confusing. So let's break this guy down. I know it can be divided by 4. That would be 1, let's see, 12 divided by 4. What is that? 8? It's 128. Can be divide by 4 again. That would be 32. Divide by 4 again, which is 4 times 8, and then 2 times 4, and then 2 times 2. You know what? I'm going to leave the 4s there because I know that those are all perfect squares. Okay? I like perfect squares. So, the square root of 4 times 4 times 4 times 4 again times 2. And then we also have those. I'm going to break this apart and then put m squared and m. So I know the square root of 4 is 2. 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 The square root of 2 doesn't exist in a rational form, so we're just going to leave it under the radical. The square root of m squared is m, and the square root of m we don't know because it doesn't have a buddy. So this guy had a buddy, this guy had a buddy, that guy had a buddy, this guy had a buddy, this guy did not have a buddy, this guy did have a buddy, and this guy did not have a buddy. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and so I have 16 with that m, and then under the radical I have 2 times m, which is 2m, and that's simplification of radicals. Alright.